Okay, so we are on page 14 for today, and then you need that set of data that I gave you, all of our information from yesterday compiled into a couple of different graphs, okay, organized in a few different ways. What we're going to look at today is how to get our calculators to do the heavy lifting on these computations. So we've got, for the cereal box puzzle, I've got how many pieces people were able to get together, and then how many people got that many pieces together. So as I'm reading this, this is what we call a frequency distribution. It shows me the frequency of the responses that I got. So I had 3 people that got 2 pieces of that puzzle together. I had 2 people that got 5 pieces of that puzzle together. That's what we're seeing here. Number of puzzle pieces they got together, how many people got that number of puzzle pieces together, okay? On the back side, don't flip out, remember, was the pencil game. So I'm looking at the greatest number of pencils that you reported being able to toss in the air, flip in the air, and catch, okay? 2 people were able to do that with only 4 pencils, okay? I had several people able to do 10 pencils, so I had 10 people that could catch 10 pencils. I had 2 people that were able to catch 16 pencils as their highest number. That's what we're looking at here. This is what we call a histogram, okay? Representing that information with bars. And then the last graph that we're gonna look at here is a dot plot, and you've seen all of these before. Just a reminder for our dot plot, this was the chapstick where you had to transfer it between the desks with the chopsticks. So this was how long it took you to move all the chapsticks. So I'm looking at number of dots here. That represents how many people took that many seconds. So I had 1 person that got it done in 5 seconds. I had 1, 2, 3, 4, 5 people that got it done in 10 seconds. I had 2 people that were able to complete that in 20 seconds. So does it make sense what we're looking at here? Okay, what we're seeing represented in this data. So what we're gonna do is use these 3 different representations of information to be able to find mean, median, mode, range, and standard deviation, okay? And I'm gonna show you how to get your calculator to do the heavy lifting on most of this so that I don't have to type in, like we did in Algebra 1, 2, 2, 2, 4, 4, 4, 4, 5, 5, 6, 6, 7, 7. That's what we did in Algebra 1, right? We took that information and we typed in those individual values. We're going to go through the same calculator commands, but this time I'm going to show you how to do a frequency list with your values so that you don't have to type in all of those individual values by themselves. So on your calculators, we're going to go to a list and spreadsheet. Okay, we're going to make a little spreadsheet of this information. We're going to start with the frequency distribution because I think this is the easiest thing to like visually see how it lines up with the spreadsheet in your calculator. So I need to label my columns here. So up at the top, I'm going to call this, let's say, N for number of pieces. You can call it X if you want, or A, or you can type out number of pieces, whatever you want. Give it some kind of label and hit enter. And then I'm going to arrow over and up into the label for the next column over. And I'm going to type FEQ for frequency. If you just want to type F, that's fine. I'm going to type something a little bit longer here. That way I make sure I remember that that was my frequency. Okay, so I'm labeling 2 columns. Again, this is a little bit of a modification from what we did in Algebra 1 when we did these. Okay, and now in the first column, N, I called it N for number of pieces. I'm going to type in all of my number of pieces. So I'm going to type in 2, 4, 5, 6, 7. Notice there's some gaps in here because I didn't have responses for 3. I didn't have a response for 20. I didn't have a response for 1. Okay, so I didn't type those in my table. I don't need to type them in my calculator. I'm going to type the number of pieces in that N list. Okay, the data as I see it. So this is 2, enter, 4, enter, 5, enter. You should be doing the same thing on your calculator. 53 is a little suspicious to me. Once I've typed in all of the n's, I'm going to go over to the next column, that frequency column, and I'm going to type in all the values in our frequency column from our paper. Okay, so when we had 2 pieces, our frequency was 3. So I'm just going to type in all of these values. I'm going to check as I type them in to make sure that they line up how they're supposed to, right? I make sure the 6 lines up with the 7, the 4 lines up with the 8. But I'm going to now type in all of my frequency values. Okay, so I'm going to pull my calculator back up and type in those frequencies. So 3, 4, 2, 2, so on and so on. And again, you are doing this on your calculator as well. When you hit the end of your list, make sure you do hit enter. And so you can see for this frequency distribution in particular, what I've recreated in my calculator looks just like what's on my paper, yeah? Okay, it looks the same. That's why we started with this. I think it's the easiest to be able to say, oh, here is what I have typed in my calculator. Once I have all that information entered, I like to arrow over to the next row and then scroll back up to the top. You're going to end up having to scroll back up to the top anyway, so I do it now. That way I don't have to scroll to try and find the stuff once it spits out from my calculator. So what we're going to have our calculator do now is something that we did in Algebra 1. We're going to have it calculate the mean, the standard deviation, the median, all that stuff. It's going to find it for me, okay? In elementary school, when you learned about mean, you said I have to add up all the values and divide by how many there are. That would be very tedious here. We've got 30-something values for each of the data sets that we're looking at today. Boy, that's a lot of having to type in your calculator. This is still a lot of typing in your calculator, but it's less than having to type 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 4 plus 5 plus 5 plus 6 plus 6. Like, that takes forever, right? So we can get our calculator to do that a little bit faster. And then in the time we typed all this stuff in, it can find not just the mean, but the median and the standard deviation and all these other important pieces for us. So that's why we're going to use our calculator for these. Okay, so what I'm going to do now is hit the menu key. And as you're going through, I know sometimes we get a little sort of trapped in the menu land on the calculator. This is somewhat intuitive, or it should be a little bit intuitive. It's not, the menu like titles aren't designed to be confusing. Okay, so if I need something and it's not a button on my calculator, it probably lives in the menu. And then we are in our chapter on statistics, right? So I probably want statistics, okay? I want to do some calculations, right? I want to find the mean, the median, the mode. So I want stat calculations. We live in one variable land for Algebra 2, just like we did for Algebra 1. So one variable is what I want. And we're always going to say one list, okay? Now I know that we wrote 2 lists, but we're just going to say one here. It's talking about number of lists that I put data in. Okay, remember, one of my lists is frequencies. That's not new data. So the default is one list. That's what I'm going to keep it as. My X list or X1 list is where I put my data. That was number of puzzle pieces. So I want to select N here. And then my frequency list, this is the part that we didn't do in Algebra 1 that I'm giving you guys now since our amounts of data are bigger. Frequency list, okay, is what we called frequency, FEQ, FREQ, I should say. So instead of having to type all of those individual values in one enormous list, I sort of bunched them, right? I said we had this many 2s and this many 3s and this many 4s. So that's our frequency list there. It's telling my calculator how many of each of these values I had. So this is the new piece for this year, okay? Now, once I've got those in, I'm gonna go ahead and hit okay. And then this should look familiar, okay? We did this last year. You got your calculator to give you this information last year. So let's review what some of this means, okay? X bar, that's what this thing is called, the X with the little like line on top of it, the little hat on top of it. That's our mean. So as I'm looking at my Breakfast of Champions summary information here on page 14, my mean is not, I'm gonna round to, well, it's 2 decimal places here, so I'll keep that. It's 9.65. So remember, mean, if you need to make a note to yourself, is X bar for the purposes of your calculator. And that was 9.65. Okay, 9.65. As I go down through this list, we don't need these, that kind of goofy looking E here is for summations. We're not going to use that in our stats material. If you take dual credit, you might use that, but we don't need it for here. The next thing that we need is this goofy looking O. That's standard deviation. So that like O with the curly Q off of it, like O and it's got like a cowlick there. That's standard deviation. Okay, so our standard deviation is 7.9 something. So if you need to make that note to yourself, standard deviation looks like that. And our standard deviation here from our calculator was 7.986. So the first two things I saw were mean and standard deviation. And then I'm gonna keep trucking through this information. N is how many pieces of data I had. So how many people responded? How many people did this game yesterday out of those 3 sections? 40 people typed in responses. I had 40 different responses. Okay. I have a minimum value here, min X. That's my minimum X value. Here are my Q's, my quartiles from our box plots back in Algebra 1. There's my median. Our median here was 8, so I'm going to jot that down. No special symbols there or notation, it just says median. And then it doesn't come right out and tell me the range, but it does tell me the minimum and maximum values. And so to find the range, I'm going to take my maximum, which was 53, and subtract my minimum, which is 2. So I have a range of 51. It doesn't, again, directly give you the range, but it gives you the information you need to find it. The other piece of information you don't directly get from your calculator is the mode. If I've got a histogram, pretty easy to find the mode, right? It's going to be the tallest bar. Dot plot, same idea. It's going to be the tallest tower of dots. In our frequency distribution, we're going to have to look for what had the greatest frequency. So which of these occurred the most often? What's our biggest frequency number? 7. Yeah, 7 occurred 6 times. So that means our mode, our most occurring value would be 7. Okay, so our mode here is 7. The most people were able to get, or 7 was the most occurring number of puzzle pieces people were able to line up from the cereal box puzzles. Okay. Now, again, this should look pretty familiar from Algebra 1. We found all of these things from Algebra 1. The new part is that frequency list. So we're going to take a look at one more together. So I'm going to take a look at that don't flip out data. So on the other side, don't flip out with our histogram. Remember where you put the pencils on the back of your hand and flipped them in the air and caught them? Okay. Right off the bat, let's go ahead and identify our mode. What's our mode here? 10, right? Tallest bar is 10. So I'm going to go ahead and jot down my mode. And then to find all of these other pieces, I could find the range from here. I know my greatest value was 30. My smallest value was 4. So if you wanted to do that right now, you could too. 30 minus 4 for my range. If you've got a pretty jumbled up list, then I might just wait for the calculator to spit out the minimum and the maximum. If it's organized the way that it's presented to me, those values, if they're organized already, then I can go ahead and find the range from there if I want to. So this would be 26 for my range. And then it's these other 3 pieces that I really want to use my calculator for. Okay, so I'm going to pull my calculator back up. And I'm going to keep N as my number. This time I'm going to let it stand for number of pencils. So the values I'm going to enter in N will be 4, 6, 7, 8, blah, blah, blah. These numbers along here. And then my frequencies will be how tall these towers are. Now I want you to notice that the sort of grid lines here go by 2s. If it's between, these were only whole numbers because we were catching pencils, okay? So this would be 1, this would be 5, okay? If it's in between 2 grid lines, it's got to be that odd number in between there. So let me pull up my calculator, and you can, if you want to, add a new spreadsheet, label your column something different. You can go back to the home screen, wipe this document, trash it, get rid of it, make a brand new document if you want to. Here's what I like to do. Now, I will say, if you get stuck on something and you need to ask questions, keep that spreadsheet so that I can look at it and help you and we can go over any questions. But the other thing that you can do is just write over the data that you have. So we're doing number of pencils now. So my N, I want to start at 4 and then 6 and then 7. I'm writing over my old data. Do you see that? I'm changing it. I'm just typing over the numbers that I already had. Now, I want you to notice my don't flip out data ends at 30. I've got some extra stuff down here. So I need to get rid of those extra pieces. I'm going to want to delete them from the bottom up. Here's what happens if I don't. So if I delete this from here, see how it gives me that little underscore line? That will cause me problems later. So what I want to do is delete from the bottom up. So if I delete from the bottom up, I get this little message here about dimension mismatches. Well, that's because I'm making this first list shorter than the second one. I'm going to shorten the second one too here in just a minute. So that's okay. I know that it's going to be shorter. I want it to be shorter. But when I delete from the bottom up, see how I don't have that underscore mark anymore? That's the goal. I don't want that underscore mark. There's that same error message. That's okay. I'm going to go up here and delete again. It gives me that dimension mismatch. That means the columns are not the same lengths. That's okay. I want to get rid of it. Okay. No underscore marks. And then I'm going to do the same thing over here. It gives me that error message again every time saying, hey, your columns aren't going to have the same amount of things in them. Yeah, I know. Okay. So now when I finish off that frequency column, it'll end where it's supposed to. So I'm going to go over to the frequency step and I'm going to enter how tall each of these bars were. So 4 was 2 tall, 6 was 2 tall, 7 was 1 tall. Again, I'm entering the heights of my bars here. Okay. So I rewrote over that histogram data with, or our frequency distribution data with our histogram data. And then because I kept this on the same page, this is why I kept getting those error messages. Look at what happened. This is all updated now. That's why I like doing it on the same page, as long as I'm not having any issues. If you rewrite over your data, you don't have to go through all the menu stuff again. It automatically updates. So I can see that my mean here is 11.55. We'll do 2 decimal places there. I can scroll down and see my standard deviation is 4.949. We already did our range, but it updated my minimum value to 4 and my maximum value to 30. So I could find my range there if I needed to. And then my median is 10. It updated all of that information from the first time I typed it in, okay? Again, you don't have to do that. You can do a brand new page every time if you like. But if I've already done the work to set it up, I like to take advantage of that. Okay, so you've got one left. You've got your dot plot left. We'll come back to that in just a minute. Okay, I would like now to turn to page 15. Put my calculator away here. And I want to take a look at a couple other types of problems that we can see. Okay, some of these are pulled directly from the SAT. So you are going to see questions written just like this in about a month or so when you take the SAT. So on page 15, number 1 says the heights were reported for 100 students in a high school orchestra. So here's our height frequency distribution, right? I had 4 people that were 4'10". I had 4 people that were 4'11". I had 10 people that were 5 foot even. What's the range in inches for the data collected? Okay, the range in inches. So what's that height difference in inches? These problems get tricky because you want to just take the biggest number minus the smallest number. Okay, but remember, I care about the height. What's the biggest difference in height? So I need to look at inches here. So I'm taking 5'7" and subtracting 4'10". I want to know what's the difference in inches between those two. Okay, because we're talking about converting between inches and feet, this is maybe a tiny bit trickier, but we're looking at, let's say, if I were to go down to 4'7", that would be 12 inches. I'm 3 off of that. So I would get 9 as my range in heights here. I'm 3 inches away from being a foot difference. Does that make sense? You could also count this off. 7 inches would get me down to 5 foot. Another 2 would get me down to 4'10". A couple different ways to think about that. Number 2, we've got a histogram here. The bar graph below represents the students or the grades that students in Mr. Kriski's class received on an exam. What's the median score? I could, if I wanted to, type this in my calculator. 4 people got a 60, 8 people got a 70, 6 people got an 80, 10 people got a 90, 3 people got 100. I could recreate that in my calculator the same way we just did with that don't flip out histogram. You could also, for a smaller problem, do this the way that we would have approached it in Algebra 1, which is to say this is 4 people, this is 3 people. So 3 here knocks out 3 here, the 4 here would knock out 1 here, and count towards the middle. Where's my middle gonna land? Somewhere in here. It's gonna land at that 80. Go ahead and turn the page. Number 3 is a type of mean question that we really love to ask. Mean, but you're missing a piece of information. Anton has grades of 87, 83, 74, and 89 on 4 of his 5 tests. What grade does he need to get on the last test so that the mean of all his scores will be 85? So we know the setup for mean is to add up all my scores and divide by how many there are. So there's going to be 5 total tests. The tricky part is I don't know what that last score is yet, but I do know I want my average, my mean, to be 85. So I'm solving for that X value here. Okay. So what I want to do is add up the scores for everything I know so far. That's 333. And now I'm dividing by 5. If I multiply by 5, I won't have a fraction anymore. So I'll have 333 plus X equals 425. And then get X by itself. And that's my last score. So I need to get a 92 on that last test to have an average of 85. Number 4 is the same idea, except for I've added a piece of information. So the mean grade on a test taken by 15 students was 70. So when I had my total and divided by 15, the mean was 70. When I had my total and divided by 16, the mean was 71. What did that last kid get that it bumped up the mean by a point? So this is my scores for, we'll say 15 people. All my scores added up for 15 people, divided by 15, gave me 70. So let's figure out what that total was. Okay, the scores for all 15 people before I would divide by 15, right? If I undo that, I get 10,050. So this was 10,050 plus the score for that 16th person, or plus X. I'm gonna have to use more complex notation here. So when I add in that extra score, we're dividing by 1 more, and our mean has changed. Now this is the same problem that we had up here, right? I've already combined the like terms. We're gonna multiply both sides by 16, and I get 1050 plus X equals 1136. Subtract 1050 from both sides to get that last score. So this started out a little bit differently, but we ended up solving the same problem that we did for number 3. So we would get an 86 was that last student score. Questions for me on those mean problems. You guys have seen problems like this before. I gave them to you in Algebra 1. You saw them before you got to me, even if you had me in Algebra 1. These are not new, okay? This one, the format's a little bit different. Problems like this, for sure, I know you've seen before. Let's talk about median then for a second. Okay, so these were mean problems. Let's talk about median. Remember, median is that number in the middle. Okay. The grades on Ms. Abdinor's algebra test were as follows. Nina took the test after everybody else, but the class median score did not change. So the median stayed the same. Well, let's see what the original median was. So 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. So our original median was an 87. On the middle, my scores were already in order, so that made it a little easier. My median was already 87. Whatever score Nina got, the median didn't change. So what did her score have to be? It had to be the median then. If it was lower than 87, the median would have shifted lower. If it was higher than 87, the median would have shifted higher. The only way for the median to stay the same is if that's what she scored on the test. So she scored an 87. Okay, the rest of the problems on pages 16 and 17 are all of some sort of variety of what we've just done. So there's quite a few more mean problems on here. If I add in a score, how would I expect it to change the mean or the median? How would it impact the range maybe? Those are the type, or the standard deviation. Those are the rest of the types of the questions that are on pages 16 and 17. So for the rest of our class time, I would like you to finish page 14. Okay, do your data calculation for the chapstick transfer. Okay, we did all of page 15. It only had 2 problems. You've got a couple left on page 16 and a couple of problems on page 17. Okay, and that's what I want you to work on for the rest of class time. If you get stuck, if you need help, if you have a calculator issue, please ask. That's why I'm giving you class time to be able to work on this. So if you have a problem with the table or your calculator functions, you can ask for help. The multiple choice questions that you have left, and I guess they're not all multiple choice, but the questions you have left on pages 16 and 17 are mostly back to that mean stuff that we looked at with those couple examples we did together. So you can use those as a guide and again, ask questions if you get stuck or you need some help.